What does it mean to hear something we cannot name? For most of human history, the night sky looked silent. It shimmered above deserts, oceans, farms, and city rooftops with the calm distance of something beyond reach. We gave the stars stories because stories were the only instruments we had. Then over the last century, we built machines that could listen where the ear could not. Radio dishes rose from the earth like metallic flowers. Satellites drifted above weather and war. Antennas leaned into darkness, waiting for a pattern, a pulse, a whisper from the deep. What they found was not certainty. It was interruption, a burst too brief to prepare for. A signal that appeared once and never again. A structure so vast it had hidden in plain sight. A noise spread across the sky with no visible maker. Again and again, modern astronomy has encountered phenomena that arrive like knocks on a locked door. They are not proof of anything simple, not proof of visitors, not proof of intention, only proof that the universe still exceeds the boundaries of our neat explanations. That may be the most unsettling revelation of all. We often imagine science as a gradual brightening, as though every decade adds another lamp to a darkened room. But some discoveries do not illuminate. They deepen the shadows. They remind us that knowledge is not a wall we build to the horizon. It is a small air, and beyond it there is weather, distance, and silence. This is a story about 10 signals from space that resist easy answers. Some may one day yield to ordinary physics. Some may dissolve under better data. But for now, they remain where the most important mysteries always remain. At the edge between discovery and humility, where human beings keep listening and the universe does not fully explain itself. What if the universe had been speaking for years before anyone realized we had already recorded the sound? On a spring day in 2001, a radio telescope in Australia captured a flash so intense it overwhelmed its own detectors. The event lasted only a few milliseconds. Then it was gone. No alarm rang. No scientist rushed into the control room. The data was archived, folded into the quiet bureaucracy of observation, and left there like a letter no one knew had arrived. 6 years later, astronomers searching through old records found it. The signal would come to be known as the Lorimer Burst, and it changed the mood of radio astronomy almost overnight. Here was a pulse of radio energy from unimaginably far away, likely billions of light years from Earth, carrying in an instant the energy our sun releases over many hours. It did not repeat. It left no obvious calling card, no glowing remnant, no neat explanation waiting nearby. It simply appeared in the data like a footprint in fresh snow, clear and undeniable, leading nowhere we could follow. What made the discovery so haunting was not only the burst itself, but the delay. We had already seen it. We just had not understood what we were seeing. For decades, astronomers had trained their attention on the signals that persisted. Rhythms, cycles, emissions that held still long enough to be studied. But this phenomenon belonged to another grammar entirely. It was not a steady note. It was a crack of thunder in a language built from instants. The instruments were ready. The imagination was not. In the years that followed, more of these events were found. Fast radio bursts, they were called. Some appeared once and vanished forever. Others repeated with baffling irregularity. Theories multiplied, magnetars, collapsing stars, collisions in distant galaxies. Each explanation seemed to fit part of the puzzle, never all of it. And so the first great question of this story emerges quietly. How much of reality escapes us not because it is hidden, but because we have not yet learned the form in which it arrives? Could a single word in red ink become one of the most enduring questions in modern astronomy? In August of 1907, an astronomer named Jerry Amon was reviewing a long sheet of computer printout from the Big Ear radio telescope in Ohio. The page was filled with ordinary-looking strings of numbers and letters, the quiet grammar of machine observation. Then one sequence broke the pattern. It was so unusual, so clean, so sharply above background noise that Amon circled it and wrote one spontaneous note in the margin. Wow. The signal lasted for just 72 seconds, exactly as long as Big Ear could hold any one point in the sky in its fixed gaze before Earth's rotation carried that region onward. It came from the direction of Sagittarius. More intriguing still, it appeared near the hydrogen line frequency, a narrow band long imagined by scientists as a sensible place for any civilization to transmit across interstellar space. Hydrogen is the simplest and most abundant element in the universe. If strangers wish to announce themselves with physics as their common language, this would be an elegant place to begin. And yet, the elegance is what makes the silence afterward so difficult to forget. Astronomers looked again. Then again. Decades passed, the same patch of sky was revisited with better equipment, better methods, and greater patience. Nothing returned. No echo, no follow-up, no repeating beacon to guide interpretation. The signal remained alone, suspended in history like a door that opened once and never again. Many explanations have been proposed. Some involve natural hydrogen clouds, some instrumental quirks, some fleeting cosmic coincidences. None has closed the matter with complete confidence. That uncertainty is what gives the wow signal its strange durability. It does not prove that anyone was there. It only refuses to become ordinary. Perhaps that is why it lingers in the public imagination. Not because it answered the question of whether we are alone, but because it distilled the experience of listening itself. A brief surge of meaning, followed by a silence so immense it becomes part of the message. What are we meant to make of a signal that seemed to keep time like a clock and then disappeared before we could understand the mechanism? Near the crowded heart of the Milky Way, where stars gather in impossible numbers and gravity shapes every horizon, astronomers in 2004 detected something deeply unusual. A source of radio emission flared to life in pulses that lasted about 10 minutes each. The burst returned roughly every 77 minutes, steady enough to suggest order, strange enough to resist every familiar category. After several cycles, the source fell silent. It was given a technical name, as these things always are, but the designation did little to reduce the mystery. Pulsars were known to blink, but far more quickly. Magnetars could erupt, but not with this measured rhythm. Binary systems danced through complex interactions, yet none matched the pattern cleanly. The objects seemed to inhabit the borderland between astrophysics and metaphor, where a signal can look almost intentional without offering proof of intention. Its location only deepened the fascination. The galactic center has long occupied a special place in scientific imagination. It is dense, energetic, ancient. If one were forced to imagine where a civilization might place a beacon meant to be seen across a spiral galaxy, it would be difficult to ignore such a region. Not because there is evidence for such a thing, but because the thought arises naturally from the geometry of the place. A message from the center would radiate outward through a billion possible nights. And yet speculation can become a mirror, reflecting our hopes more clearly than the sky. The more disciplined truth is harder and more interesting. Something emitted those bursts, and we still do not know what physical process produced them. For 20 years, follow-up searches have struggled to recover the same pattern. The source offered a handful of appearances, enough to establish its reality, not enough to make it familiar. That may be the quiet lesson here. The universe does not owe us repetition. Sometimes it reveals itself in fragments, as though reminding us that recognition depends not only on what exists, but on whether we happen to be looking during the brief moment when existence becomes visible. What changes when a mystery that was supposed to happen only once begins to return, again and again, on a schedule of its own? For years, fast radio bursts seemed to belong to the category of cosmic accidents. They arrived without warning, delivered impossible amounts of energy in a sliver of time, and vanished before anyone could ask a second question. Then astronomers, studying a source first detected in 2012, found something that altered the emotional structure of the problem. This burst came back. The source, known as FRB 102, was traced to a small galaxy billions of light years away. At first, the repetition felt like a gift. A repeating burst could be revisited, measured, localized, compared against itself. It offered what one-time events never could, the possibility of familiarity. But the more scientists listened, the stranger the source became. Dozens of bursts became hundreds. What had seemed like a singular anomaly turned into a persistent behavior. Then another layer emerged. The activity appeared to follow a cycle, active for a span of weeks, quiet for a span of weeks, then active again. Not perfectly mechanical, not simple enough to be called a clock, but structured enough to suggest a system with conditions, phases, and hidden architecture. Some researchers imagined a neutron star orbiting a companion. Others proposed the wobble of a magnetized remnant or interactions inside an environment unlike anything nearby in our own galaxy. Each idea explained something. None explained everything. There was also the backdrop, a steady, compact radio source surrounding the repeater, as though the bursts were rising out of a larger and still unidentified engine. It was not merely a flash in darkness. It was a voice speaking from within a chamber we do not yet understand. That distinction matters. A single burst can be filed under catastrophe. Repetition asks for a deeper story. Perhaps that is why this source has held the attention of astronomers so firmly. It reminds us that nature often becomes most mysterious, not when it is chaotic, but when it begins to show order just beyond our reach. Pattern is comforting until we realize we cannot read it. Then pattern becomes its own form of silence. What happens when a signal seems to come from the nearest possible place we would hope to hear one? In 2010, astronomers involved in the Breakthrough Listen project turned a radio telescope toward Proxima Centauri, the small red star that lives just over 4 light-years from Earth. It is our nearest stellar neighbor, close enough in cosmic terms to feel almost intimate. Around it circles at least one rocky planet in the star's habitable zone, a world that has stirred scientific imagination ever since its discovery. If there were ever a system capable of making humanity lean forward in its chair, this was it. Then a narrowband signal appeared. It was later named BLC-1, short for Breakthrough Listen Candidate 1, and it carried several of the traits researchers are trained to notice. It showed up when the telescope was pointed toward Proxima Centauri and disappeared when it turned away. Its frequency behavior suggested motion relative to Earth, the kind of drift one might expect from a source on a rotating planet. For a moment, the ordinary caution of science had to share space with something more fragile and more human. The possibility of significance. That possibility did not last unchanged. Further analysis pointed toward a more familiar explanation, likely some subtle interaction among human-made radio signals. Yet even this resolution remained incomplete in tone, if not in direction. The team could not point to one simple machine and say with finality, this was the cause. The candidate dissolved, but not into certainty. It dissolved into likelihood. And perhaps that is why BLC-1 remains memorable. It was not the strongest signal ever found, nor the longest lasting. What made it resonate was proximity. The question was no longer abstract, no longer tucked inside a galaxy unimaginably far away. It hovered around the nearest star, around a world that exists not in myth, but in catalog and orbit. Science did what science must do. It tested, doubted, reduced the extraordinary claim back toward the ordinary. That discipline is not disappointing, it is honorable. And still, one feeling lingers after the analysis is over: how quickly the human heart can populate the silence between data and conclusion, especially when the silence comes from next door. Can a message appear to arrive from nowhere at all? In the early 2000s, a curious signal surfaced through SETI at Home, the vast distributed computing project that invited ordinary people to donate spare processing power in the hope of finding something unusual hidden in telescope data. There was something almost democratic about that dream. Millions of quiet machines in kitchens, dorm rooms, and home offices helped sift the sky together, as though the search for company in the universe should belong to everyone. Among the candidates, one signal stood apart. It had been detected multiple times from the same region of space and at a frequency that long held symbolic importance in the search for extraterrestrial communication: the hydrogen line. The signal was designated SSGB0214A, an unromantic name for a phenomenon that inspired an outsized amount of curiosity. It seemed, at least for a moment, to satisfy several of the conditions people had imagined for an intentional transmission. But the deeper researchers looked, the less comfortable the picture became. The apparent source region did not offer an obvious home. No nearby star system neatly matched the coordinates. No familiar object sat there like a convenient answer waiting to be claimed. More puzzling still, the signal's frequency drift suggested motion too extreme for an ordinary planet to manage easily. If interpreted one way, the source would have to exist in conditions that strain common assumptions about stable worlds and natural emitters. If interpreted another way, The entire event might have been an unlikely artifact, a false pattern rising from noise and hope. That is often how the strangest cases persist, not because they prove something extraordinary, but because every available explanation feels incomplete in a different direction. There is something moving in that tension worth noticing. We tend to imagine mystery as a curtain hiding a final revelation. Yet some mysteries do not conceal a single answer. They reveal the fragility of our categories. Empty space, after all, may not be empty in the ways we once believed. And when a signal seems to come from a place where nothing should be speaking, the deeper question may not be who is there, but how often the universe unsettles us by refusing to honor the map we have drawn of it. What are we supposed to feel when the universe reveals structures so large they should have been obvious, yet remained invisible for most of the history of modern astronomy? In 2020, while examining radio survey data from Australia, astronomers noticed something that seemed almost too clean to be real. Immense circular forms suspended in deep space, visible only in radio light. They were not small artifacts at the edge of detection. Each ring stretched across distances so vast that entire galaxies could sit comfortably within them. And yet, until recently, no one had recognized them for what they were. They came to be known as odd radio circles. The name is modest, almost casual, but the phenomenon is not. These structures appear as enormous halos, often associated with distant galaxies, though not always in ways that settle the matter. They do not glow in visible light the way many known cosmic structures do. They do not present themselves neatly in X-rays or infrared observations. They seem to inhabit a narrow window of perception, as if the universe had chosen one wavelength and one wavelength only in which to disclose them. Scientists have proposed several explanations. Perhaps they are the after-image of galactic collisions, shock waves moving through ancient plasma, or the remains of violent outflows from energetic galactic cores. Each theory offers a path toward understanding. None yet closes the circle completely. The symmetry is difficult. The scale is difficult. The selective visibility is difficult. The objects seem less like violations of physics than reminders of how partial our inventories still are. That may be the true force of the discovery. Not merely that these circles exist, but that they existed all along, while our instruments, surveys, and assumptions passed over them. There is a humbling thought hidden there. We often imagine ignorance as darkness waiting for better light, but sometimes ignorance survives in full view, embedded in the data, present for years, waiting not for sharper eyes, but for a different question. And perhaps that is what discovery finally is. Not the moment the universe changes, but the moment our attention does. What if one of the strangest signals in this story did not come from distant galaxies, but from the uneasy border between science, secrecy, and human power here on Earth? In September 1979, an American satellite built to detect nuclear detonations recorded a peculiar double flash over the South Atlantic. To those who understood the instrument, the signature was deeply familiar. It resembled the pattern expected from an atmospheric nuclear explosion. One burst, then another, a brief geometry of light associated with violence and precision. And yet, almost as soon as the data appeared, certainty began to erode. No nation stepped forward. No clean chain of evidence settled the event beyond dispute. Investigations followed, along with denials, classified assessments, technical panels, and years of argument among scientists, intelligence officials, and policymakers. Some believe the signal pointed to a covert weapons test, perhaps conducted far from public sight. Others argued for more ordinary explanations: an instrument anomaly, a stray impact, a misreading amplified by Cold War fear. The trouble was that none of the explanations erased the others. This was not the mystery of a distant transmitter. It was the mystery of interpretation under pressure. Fragments of supporting evidence drifted into view over the years. Unusual readings here. Suspicious patterns there. Environmental hints that seemed suggestive without becoming final. Every clue carried weight, but also doubt. The result was a case that never fully left the realm of signal and entered the realm of conclusion. Something happened. The instruments saw something real. But reality, once filtered through secrecy and national interest, became difficult to hold in a single hand. That is why the Vela incident belongs in a story about unexplained signals. Not because it points beyond Earth, but because it exposes how fragile truth can become even when the event itself is not imaginary. We like to think mystery survives only in distant places beyond our reach. Yet sometimes the most enduring uncertainty is born much closer, where data, power, and silence meet. And in that meeting, the question changes. It is no longer only what was seen, but what kinds of truth a civilization is capable of facing when the answer may be inconvenient. How can the universe be louder than all our theories allow? In 2006, a balloon-borne experiment rose above much of Earth's atmosphere, carrying an elegant scientific ambition. The mission was meant to listen for faint radio traces from the early universe, the delicate residue of ancient processes that unfolded when the first generations of stars and galaxies were taking shape. The expectation was subtlety, a background murmur, a signal so weak it would require great care even to detect. Instead, the instruments found a roar. The excess radio noise appeared to come from every direction, spread across the sky with a stubborn uniformity that made it difficult to pin on any one source. It was not a bright object in one corner of space, not a dramatic burst, not a transient event that vanished before confirmation. It was a condition of the cosmos itself, a diffuse brightness far stronger than known radio sources could account for. Galaxies, quasars, pulsars, the familiar catalog of emitters taken together still seemed insufficient. The numbers did not close. That mismatch is what gives the discovery its peculiar gravity. Many mysteries begin with an anomaly at the edges of data. This one sat in the middle of the sky, broad and persistent, as though the universe were filled with a hidden population of broadcasters or a physical process not yet properly counted. Researchers checked calibrations, reconsidered foreground contamination, compared models, and tested assumptions. The excess remained. There is something almost philosophical about such a finding. A single strange object can be dismissed as an exception, but a signal from everywhere asks more of us. It suggests that ignorance is not always local. Sometimes it is woven into the background of experience, so constant that we mistake it for completeness. We tend to fear silence in the cosmos because silence can feel like absence. Yet this mystery offers the opposite discomfort. The universe may not be empty or mute at all. It may be crowded with emissions, histories, and mechanisms we have not learned to separate. And so the question turns quietly in the dark. If the sky is already overflowing with unknown sound, how much of reality have we mistaken for static simply because we do not yet know how to listen? What if the most unsettling pattern is not a single burst, but a long sequence that grows more mysterious the closer we study it? In September 2022, radio telescopes detected a fast radio burst from a source relatively nearby by cosmic standards, roughly 100 million light-years away. It was labeled FRB 2022-09-2A, one more entry in a growing archive of strange celestial events. But this source refused to remain just another catalog number. Over the following weeks, it produced hundreds of bursts, turning a fleeting anomaly into a rich and unnerving body of evidence. At first glance, some features were familiar. The burst swept from higher frequencies down to lower ones, a descending pattern astronomers sometimes describe with informal humor because it resembles a falling musical note. But beneath that recognizable behavior was something harder to dismiss. When researchers examined the full collection of bursts together, comparing their timing, spectral shape, and energy distribution, they found structure that did not settle comfortably into existing models. The signal was not random noise. It was not simple repetition either. It lived in a more difficult territory between disorder and design. That territory is scientifically dangerous in the best way. It tempts the imagination, but it also demands restraint. Natural explanations remain possible. Perhaps the engine is a young, highly magnetized object embedded in an environment more dynamic than current theories usually assume. Perhaps plasma, motion, and geometry are combining in ways our models still oversimplify. Yet the data has continued to resist easy classification, even under careful analysis. What makes this source especially important is not merely that it is strange, but that it is generous. It has given researchers abundance rather than scarcity. Instead of one brief clue, there are hundreds. Instead of a vanishing point, there is a pattern dense enough to test and retest. And still, the underlying mechanism stays elusive. There is a human lesson in that abundance. We often believe more data will naturally produce more certainty. Sometimes it does, but sometimes a richer signal only reveals a richer ignorance. The closer we move toward explanation, the more clearly we see the limits of the language we brought with us. And somewhere beyond those limits, the source continues to speak. What do these signals reveal about the instruments we trust, the categories we inherit, and the human mind that stands between raw data and meaning? By this point in the story, the mysteries have begun to overlap. A burst hidden in an archive for years, a signal heard once at the hydrogen line and never again, a rhythm near the galactic center that felt almost mechanical, a nearby candidate that stirred hope before retreating into uncertainty. Vast radio circles, a skywide roar, repeating bursts whose internal structure resists the neat vocabulary of known astrophysics. The details differ, but the deeper pattern is beginning to show. Again and again, the universe has not simply surprised us. It has exposed the narrowness of our expectations. We build instruments to answer certain questions, and in doing so, we quietly teach them what to notice. We search for persistence and miss the millisecond flash. We search one wavelength and overlook a structure the size of galaxies. We assume the background is understood, only to discover the background itself is louder than our models permit. Even when the data is already in hand, recognition can arrive years later, dependent on a new algorithm, a new theory, or a person willing to ask an unfashionable question. That is not a weakness of science. It is one of its most honest features. Science does not begin with omniscience. It begins with partial vision and methods for correcting it. The trouble is that each correction often reveals not closure but additional layers of mystery, and perhaps that is why these signals matter beyond astronomy. They resemble other forms of human experience. Memory works this way. History works this way. We live among fragments, misread patterns, delayed realizations. We return to old evidence and discover that it means something different now, because we have become different observers. In that sense, the deepest unknown may not be the signal itself. It may be the gap between what the universe is doing and what the human mind is prepared to perceive. The sky is not only a frontier of objects, it is a frontier of interpretation. And every unexplained transmission asks the same quiet question. When the next message arrives, will we recognize it for what it is, or only for what we already know how to see? What remains after the data, the models, the debates, and the years of patient listening is not merely a collection of anomalies. It is a portrait of our era, a civilization advanced enough to detect whispers across billions of light years, and humble enough to admit that many of those whispers still cannot be translated. That admission matters. We live in a time that often mistakes information for wisdom. We assume that with enough sensors, enough computing power, enough archives and networks and machine learning, mystery will steadily retreat. Yet the signals in this story suggest something more subtle. Knowledge expands, but so does the shoreline of the unknown. Every answer redraws the boundary and reveals a wider sea. There is beauty in that, though it is not always comfortable beauty. A one-time burst can become a lesson in attention. A repeating pattern can become a lesson in patience. A false alarm near a neighboring star can become a lesson in scientific integrity. A sky filled with unexplained radio brightness can become a lesson in scale, reminding us that the universe may be stranger in its ordinary background than in its rare spectacles. Even ambiguity on Earth, as with disputed signals shaped by secrecy and history, teaches that the challenge is not only to gather evidence, but to create cultures capable of confronting it honestly. So perhaps the meaning of these signals is not that they point toward one grand solution, waiting just beyond the horizon. Perhaps their meaning is more human than that. They remind us that curiosity is not the opposite of uncertainty. It is the discipline of staying present within uncertainty without forcing it into myth or panic or premature belief. We keep building better instruments. We keep turning them toward the dark. And somewhere in that ongoing act is a quiet kind of dignity. To listen carefully, to resist easy answers, to remain open without becoming careless. The universe has not yet explained all that it has said, but maybe wisdom begins there in the willingness to keep listening long after certainty has failed to arrive. So where does this leave us after the bursts and circles, The roaring background, the vanished transmissions, the patterns that almost resolve and then slip back into uncertainty. Perhaps it leaves us where all meaningful inquiries eventually arrive, not at a final answer, but at a more honest relationship with mystery. The sky above us is no longer the silent dome our ancestors imagined, yet it is not fully legible either. It is alive with structure, noise, memory, and signals crossing distances so vast that language begins to thin out under the weight of them. Some of what we have explored in this journey will almost certainly become ordinary with time. New theories will emerge. Better instruments will separate one phenomenon from another. A few of today's enigmas may become tomorrow's textbook paragraphs. That is the patient triumph of science. But not all value lies in resolution. There is also value in the posture these mysteries ask of us. They ask us to be rigorous without becoming arrogant, imaginative without becoming reckless, humble without surrendering wonder. In an age that rewards instant conclusions, unexplained signals offer a quieter kind of education. They remind us that the world is not obliged to fit the speed of our appetite. Some truths reveal themselves only slowly. Some remain partial for generations. Some may never yield completely, and still they enlarge us by being contemplated with care. That may be the most human thread running through all of this. We are a species that listens into darkness. We build delicate instruments, send them into deserts and mountains in orbit, and wait for the faintest irregularity. We do this not only to master the universe, but to place ourselves within it more truthfully. To know what is out there, yes, but also to discover what sort of beings we become in the act of asking. And so the story does not end with certainty. It ends with attention, with the sense that somewhere, even now, another signal may be passing through the dark, crossing cold distances, touching an instrument on Earth for a fraction of a second. A brief arrival, a pattern not yet named. A reminder that memory, truth, and the future are all shaped by what we are willing to hear before we understand it.